looking for page 975. And they dared not to actually write it down. They gave the formula. Dang it. Would someone to look up the speed of light?
Two
299,792, 458 meters per second. All right. So this is the speed of light, and this is the speed of an electromagnetic wave. Pretty darn close to each other. So Maxwell comes to the conclusion, actually he speculates, that light might be an electromagnetic wave. It turns out he was right. And physicists around the world, we will assume, well, actually as far as they were concerned, all over Europe and, well, they probably didn't care about the US at that point. So physicists all around Europe looked at that and said, wow, that is actually incredible work. But there's a mistake. Why would someone claim that there's a mistake here?
Because it's faster.
Looking at that speed of light.
Because it's faster than the speed of light?
Excuse me?
Because it's faster than the speed of light?
No, that's just a rounding thing. It's an issue with speed in general.
Relativity.
Keep going, or you just tossing out words.
I would assume, because there's not really, I guess they didn't have a way to show that he was right, like physically. So it's-
Actually, they did. There were experimental values for the speed of light. There had been various attempts at it. Galileo tried it, and his method of trying to find the speed of light was he figured human reaction would be set time, and so he had some flunky stand on a hill with a lantern, and he was on another hill with a lantern, and one person would take the light, shine it, and close it, and the other person would see the light, take and close it, and they would time how long it would take for between the first person flashing the light and then seeing the light returning. And then they went to a greater distance, figuring human reaction would be the same time to try to calculate the speed of light that way.
Did it work?
They concluded that light is, if not infinitely fast, it is very, very fast.
So,
It did not work.
so speed's relative to you, the spectator, right?
Is it?
Yes. Well, because when we were looking at something in 151 where if you're moving along, if I'm moving at some speed and another object is moving at the same speed along next to me in the same direction with me, then that object doesn't look like it's moving.
Okay.
If the object is moving against me, it is moving.
And that's the essence of the complaint. There's nothing in here about the speed of the observer.
Yeah.
All right, one other thing I just told the way of Galileo tried. If I shine a light against a mirror, the light's gonna go there and come back. If I have a cog with teeth on it and I start rotating it, if I rotate it at a certain speed, I'm not gonna see the light because the light's gonna come back and hit the cog. So if I spin it even faster, basically the light's gonna shoot out one cog and then come back and sort of the next cog. And so if I know how fast this thing is spinning, I know how long time it takes the light to go there and back. I can measure that distance, measure the speed of light. That's the essence of what was done. However, back to the issue. There's nothing about the observer in here. Physicists basically, Lorentz specifically, Hendrik, something. Lorentz spent several decades trying to figure out where the mistake was. Came up with a slew of mathematics which would be used later. But Lorentz refused to take a leap. So now, we're a leap. Einstein comes along and says, suppose there's no mistake there. Oh, now I'm just picturing a bunch of grad students at some point over the course of the next 30 years looking at that and going, wait, suppose there's not a mistake there, and then being basically bullied down into saying, no, there's gotta be a mistake. However, Einstein comes along and he says, suppose there's not a mistake, that the speed of light is the same regardless of the observer. So I shine a beam of light, it's traveling at roughly 300 million meters a second, 186,000 miles per second. It's not just a good idea, it's the law. So, but if I'm traveling, let's say, half the speed of light and I shine a light, it's still gonna look the same. It's not like it's half that speed. So the observer does not matter. And then he went one step further. And he came up with a Gedanken experiment, basically German for thought. Came up with a thought experiment. Suppose I've got a mirror, and then down here, I've got a box that is cruising along at some speed v. As it's cruising along at some speed v, it's going to shine light upwards. So, but because there's a horizontal component to it, that light's going to come up here, bounce against the mirror, and then it's going to hit the box over here. The horizontal component is not affected. And so we can figure out the amount of time it should take to do that. So I know that light's traveling at a speed v, and so this distance from here to here would be v times whatever time it took. Let's make this distance here h. Or given the way I've drawn it, that distance there h. So I know I've got a triangle here. I know the distance from here to here is just going to be half of that, so that's 1/2 vt. And the distance from here to here, oh, and the distance of the height is h. And so the distance along here, well, that's the Pythagorean theorem. That would be the square root of h squared plus 1/2 vt, all that squared.
Quick question, where's the light coming from?
The box.
Cube?
The cube.
Yeah.
Yep. It's shining up and then it hits the box again.
Similar to somebody walking with a flashlight.
Yeah. Yeah, or you can think of it as he's walking along and he throws a ball through the air, and because he has a horizontal component to it, that ball also as well, and so the ball should land right back in the sands again. So I know the speed is distance over time, and so that's going to be 2 times, because it's going that hypotenuse and that hypotenuse, 2 times the square root of h squared plus 1/2 vt squared over the time. Nothing earth-shattering there, just classic. There's no acceleration to the light, just distance over time. Not much of a thought experiment. But then he said, well, let's take a look at it from the point of view of the box. So I got my mirror right here. I've got my box. It shines light and then comes right back. So from the box's point of view, the light just goes up and then comes back down. This is 0 is h. So if Maxwell did not make a mistake, then I know speed is distance over time. Distance is just 2h over time, and I'm going to put a little p here to represent, well, actually, over time. So, if this is true, what else must be true?
Time equals something.
Okay.
I feel like this next bit has to do with the time part.
Yes. I sort of spoiled some of it. Sorry about that.
Okay, so
Other people can play too. But go ahead, Ibrahim.
so time is equal to the speed over, or no, it would be 2h over the speed. So that means that, well, if the speed's not relative, is the time relative?
Yes.
Because I'm timing something, or like,
The time for the box versus the time for the person.
yeah, well, how long it takes me looking at it from this perspective, it's gonna do this thing and then come back down, but for that person, it's faster. Because that slope thing, it's gonna take a lot longer for it to do that to that, looking at it from there, than
Right.
going up and down.
Right.
Which means the speed of it's not changing, it's the time it takes.
And that was the part that Lorentz could not bring himself to admit. Because it was assumed before this that time was the same for everything. 1 second is 1 second. But it can't be. If there's no mistake in that equation, or nothing missing from that equation, then time cannot be the same. Because that can't equal that. If the denominators are the same, then the only way the numerators are the same is if v is 0. So times are not the same, and so I'm going to put a little p right there to represent that time. So now I'm going to set them equal to each other because the speed is constant, is 2h over tp. And what I want to do now is I want to solve for t, because I know the equation I want to end up with. I'm going to isolate the radical, so I get the square root of h squared plus 1/4 v squared t squared equals 2ht over tv. Actually, I want to do one other thing. I want to solve for h because h is an arbitrary value. So from this, I know that h is equal to 1/2 CTP. Plugging that in for h and squaring both sides. So I get 1/4 c squared tp squared plus 1/4 v squared t squared equals the 2's are going to cancel out, left with c tp t over tp.
Wait, what?
I feel like I've lost something in there. Squared. Oh. That 2 doesn't belong there. I'm going to 2 down here. All right. Question? Or are you about to
That was
point out
my
that mistake?
question, the two. About the two.
Okay. Yeah, that 2 goes away because they cancel. So I'm left with 1/4 c squared tp squared plus 1/4 v squared t squared is equal to 1/4 c squared t squared. Obviously, the 1/4 can go away, multiply everything by 4. Again, trusting the math people.
Can the, no, never mind. C and V can't cancel, right?
Yeah. I'm solving for t, so I need to get all the t's on one side, so I have c squared tp squared equals c squared t squared minus v squared t squared. Since I'm solving for t, it'll be factored out. And so I have c squared minus v squared times t squared, c squared, tp squared. I can divide both sides by c squared v squared. So I get t squared is equal to c squared tp squared over c squared minus v squared. This is not the traditional form of this, so I'm going to multiply top and bottom by 1 over c squared. And so I get t squared is equal to tp squared over 1 minus v squared over c squared. So I end up with, in the end, that time in the lab frame is equal to the time in the box frame over the square root of 1 minus v squared over c squared. Now I use the subscript p here because this is traditionally known as the proper time.
AKA the time from the box perspective.
The time from the motionless point of view.
Okay.
Because we're observing the time for the light to go from the box to the box. So in the first situation over there, that is definitely not proper time because we are not in the point of view from the box. But from the second point of view, the box is still, that is the proper time. V squared over c squared shows up so much that they come up with a shorthand for it, and it is a capital beta. It's a beta. This is known, never mind. It's just the speed with respect relative to the speed of light. 1 over the square root of 1 minus beta squared shows up so much, it has its own special symbol. This is a lowercase gamma. This is known as the Lorentz factor.
You said it's the Lorentz factor?
Yes. Lorentz was the big advocate that Maxwell had a mistake and spent the next several decades trying to figure out what the mistake was. Lorentz actually came up with all this math that Einstein ends up using, but Lorentz was coming up with a reason why it appeared to be different, he was not going to accept the fact that the times were different.
He was wrong.
He was wrong. He was a fundamental, I mean, the math was all right that he did, but his interpretation of it turned out to be wrong.
So Lorentz did.
Lorentz could have really made Einstein much lesser.
Word.
However, he didn't. Einstein actually in 1905 had 4 major papers, 3 of which could have gotten him a Nobel Prize. In the end, the anti-Semitism of Europe was pretty dominant, and eventually they realized they could not keep Einstein from getting a Nobel Prize, and so they decided to lump it all together and say, for contributions, and gave him 1. However, it's in the other middle. But let's set this up for a second. Therefore, if time is not the same, what kind of difference is there? So let's say that beta is 0.1. So in other words, the speed of an object is 10% the speed of light. Because beta is equal to, well, that's v over c, and so the speed of an object would be beta times c.
So beta is not the symbol for the speed of light, right?
Correct. Beta is just a way of simplifying it, so we're not constantly writing things in meters per second. So the Lorentz factor would be 1 over the square root of 1 minus 0.1 squared, which is 1 over the square root of 0.99, which is what? Someone be kind enough.
$1.005.
So
Units?
it is unitless.
Oh,
Yeah, because V over C is the units would cancel, so beta is unitless, and everything else is unitless here. So if the proper time is 24 hours, so next 24 hours, let's say I'm traveling near that speed of light to meet at age 24 hours. However, to an outside observer, one that sees me going 0.1 times the speed of light, how much time passed for that observer? Well, it would be 24 hours times 1.005 and whatever that is.
$24.12.
Hours. So the person who sees me going 10% of the speed of light actually will age 6 minutes more than I will.
What?
This is a biological difference. If I had an identical twin, and there's a number of problems with that I have with an identical twin, matter of fact, a conjoined twin, they were connected by a toenail at birth, so they are the exact same age. A pair of clippers separated them, but they are the same age. One of them gets in a spaceship, flies away, comes back. When it gets back to Earth, then the twins are no longer biologically the same age.
But did they look the same age?
No.
One would physically age,
Yes.
like one could have gray hair or something.
Yes. If you're going fast enough or going long enough, yes.